Hello, we are discussing about GATE 2014 ECE paper, and this is related to analog circuits. In the AC equivalent circuit shown in the figure, if IN is the input current and RF is very large, the type of feedback is A. Voltage, B. Voltage current, C. Current voltage, D. Current. Okay, so this is V out, this is output node, and this is what input node IN. So if you are observing, okay, this is voltage is nothing but first one is going to be first term out of this one is related to output, and second term is going to be related to the second word is related to input side. So first of all we will side output side is nothing but type of sampling we should know. So we should know the type of sampling which will give the output type, sampling type, and input side is nothing but mixing. So input side we should know about the mixing, and output side we should know about the type of sampling. So type of sampling is nothing but sampling can be either voltage or current sample. Okay, so sampling can be either voltage or current. Look at this one. If output node and feedback element is connected at same node, if output node that is nothing but output V out itself, output node and feedback element are connected at same node, at that time, that is voltage sample connected at same node. At that time we can say that one the type of sampling is voltage sample. And if it is not in that way, that is if the feedback element is going to be taken from the output loop, by that time that is current sample. Okay, current sample is nothing but if feedback is taken from output loop, then it is current sample. Okay, voltage sample is if output node and feedback element are connected at same node. Okay, at same node we should write here same node, and if feedback is taken from the output loop instead of output node, at that time it is called as current sample. So look at this one, this is output V out node, and this is RF is nothing but feedback element. So voltage across feedback element is nothing but it is connected to RF is connected to directly output node. So this sampling is nothing but here this sampling is treated as voltage sampling. So the type of sampling is voltage. So this is voltage sample. Why? Output node is connected to the feedback element. Both are at the same potential, so that it is voltage sample. And second one, mixing. If you want to know about the mixing can be of two types. Okay, it may be either series mixing or shunt mixing. If the feedback element, that is nothing but if the feedback is in series with input signal, at that time that is voltage mixing, otherwise that is current mixing. If feedback is in series with the input signal, by that time that is voltage mixing, otherwise if the feedback signal is in shunt with input side, at that time it is current mixing. So now you see here, this is I in, and it is going towards the current is dividing into in this way, so that this can be treated as IF. So IF, current flowing through feedback element, is nothing but IF, and this IF is going to be in parallel with I in, that is nothing but current divides, which implies nothing but shunt. So this mixing is called as shunt mixing, or it is called as current mixing, shunt or current mixing. So if the input signal is going to be a current signal, by that time that is always current mixing, because currents can be divided only in shunt. So it is current mixing or shunt mixing. If the input signal is voltage, by that time the signal is going to be, the mixing is going to be either series mixing or voltage mixing, because currents will divide only in shunt and voltages will be subtracted only in series. In parallel voltages are same. So If the input signal is current, directly you can say that one it is shunt mixing or current mixing. If the input signal is voltage, by the time we can directly specify whether it is series or voltage mixing. So in this case input signal is in, so that we can say it as shunt or current mixing. So the right option is nothing but sampling is going to be giving about the output side and mixing is giving about the input side. So voltage current is nothing but right option. So this is output is voltage sampling, input is current mixing. So the right option is B. And apart from this one, we will see other circuits also which are going to be useful. So look at this one. Whether this circuit is going to be what type of sampling, what type of mixing. So at sampling side, this is going to be treated as feedback element. This is feedback element. So feedback element is going to be at output node. This is output node, and feedback element and output are going to be at same potential, that is nothing but voltage sample. This is, and next at the input side current is going to be gets dividing, that implies nothing but shunt mixing. Okay, shunt, or it is also called as current mixing. Current mixing. So this is also treated as voltage shunt or voltage current. Voltage shunt or voltage current. The same feedback is going to be represented with op amp. So this op amp circuit, that is nothing but inverting op amp. Inverting op amp is also voltage shunt feedback. Voltage shunt feedback. Remember this one. Okay. Next, the other circuits are going to be looks like this one. It is going to be called as either common collector. This circuit is called as either common collector amplifier, or it is also called as emitter follower circuit. So in this one, this is RE is nothing but feedback element. This is feedback. So feedback element and output are going to be at the same node, so that this is going to be voltage sample. Voltage sample, and V input is this one, voltage across this one. Voltage across this one is going to be VF. Feedback signal is nothing but voltage across RE, so it will be in series. If you write the KVL at that time, what you will get is VBE. So you can write it as V input minus VBE minus VF is equal to 0. So here the feedback signal is in series with input signal, so that it is series mixing. So this side it is series mixing. Series mixing, or it is called as voltage mixing. Voltage mixing. So the type of feedback is nothing but voltage or voltage series. Voltage series or voltage feedback. So common collector as well as common drain are examples of voltage series or voltage feedback. Okay. This is one more circuit. What type of feedback having this one? Assume that one it is going to be connected to ground and it is given as AC equivalent. By that time, this is what output node. So this is going to be treated as V0, and this is feedback. RF is feedback and output node is taken at the second transistor collector. So if you are observing, voltage across this RF is nothing but a part of output loop. So you can take output loop in this way also towards the ground. Okay. So by that time, here feedback element, voltage across feedback element is from the output loop, it is not from the output node. So this is going to be called as current sample. Current sample. And at the input side, it is input signal is current signal, so that it is shunt mixing. Directly we can tell this one. This is shunt mixing. So this type of feedback is nothing but current shunt. Current shunt or current feedback. Current feedback. So the other circuits, if you are thinking, so this is common emitter circuit. It is common emitter amplifier, and this amplifier is nothing but non-inverting op amp. So if you are observing again, this is RE is nothing but feedback element, and voltage across RE is a part of output signal. So that voltage across RE, which is nothing but feedback voltage, is going to be taken from the output loop. So it is not voltage sample, it is current sample. Current sample, because output and feedback both are not at same node, and here voltage across feedback element is going to be a part of output. So voltage across feedback element is taken from the output loop, not from the output node directly. And here it is V input. V input is going to be in series with feedback element. If you write a KVL, you will get this one. So this is going to be treated as series mixing. Series mixing. So this is going to be CE amplifier is nothing but current series feedback, otherwise current voltage feedback. And non-inverting operational amplifier is voltage series. This is voltage series feedback. Remember this one, this is voltage series feedback, whereas inverting amplifier is voltage shunt feedback. Thank you.